From the beautiful IB wing of the Way Happy Studios, this is Mr. Meyer, and we are talking about algebraic factoring and expansion. So as you see in this blue text box here, you will notice that we have some common laws, things like distribution that you've seen, or foiling, or whatever you want to call that, also known as probably distribution for many. We also have things like difference of squares, and we have some other common ones. So make sure that you are familiar with them all, and we are going to now do them with exponents. So continuing on with our exponents love. Let's go ahead and expand this part right here. So this looks like we have a distribution, a little scary because it's got all these fractions. So I'm just going to distribute this through like normal. So they both have the base of x, so if I have that x, and then I'm going to add their exponents, so negative a half and 3 halves, remember same base, add their exponents, would be 2 halves, which most people are going to call 1, but I'll keep going, plus, now here I will also have a 2, and then the same bases, and then what happens to the base? You add them up, so x to the 0, that's kind of freaky, and then minus 3 as I go to the next one, and I will have x, same base, so I'll add their exponents, negative a half, and negative a half is negative 1. And lo and behold, we have our answer. Now let's make it a little prettier, right? It's just bad manners right now. It's a correct answer, but it's bad manners. I can write things like x to the first, which we would just leave as x, plus now 2x to the 0 is just 1, so plus 2, and then minus 3. Now x to the negative 1 means, hey, let's just move that x to the denominator, and there you go. A beautiful expansion of that problem. All right, let's continue on now in the next example. Looks like a foiling problem. All right, so a 2x times a 2x would be, again, keep the base 2 and add the exponents. X plus x would be 2x, and then 2 to the x times 1 is just 2 to the x, and then 3 times 2 to the x is just that, right? 3 times 2 to the x. So how can I write that? Plus 3 times 2 to the x. And then 3 times 1 is 3. So what do we have? Looks like, now this is a little funny. This is 2 squared to the x, so I could write this as 4 to the x plus 2 to the x plus 3 times 2 to the x plus 3. And that's about all I got. Can I multiply these together? No. Remember, please excuse my dear Aunt Sally, or maybe you learned it as GEMDAS. We do grouping first, so parentheses first, then exponents would have to have and then multiplication and division. So multiplying those together is way down the list. In fact, it comes after the exponent. So nothing I can do there. I can't even think of a good way to put that together. So that's as far as I can go there. And what about B? B, let's see. Oh my goodness. What the heck could we do there? That is, foiling. You could write it out twice. You could recognize the shortcut, right? You always have this shortcut right here for foiling, if you remember it. If it's a squared term, you just square the first, you square the last, and then you multiply them together and double it. That's that middle term, right? So I could do that. I could say we're going to square the first term. So 7 to the x times 7 to the x is just like we had earlier, 7 to the 2x, right? Then we're going to multiply them together, which would be, what, 2, and then we double it. So 2 times, what do you get when you multiply 7 to the x and 7 to the negative x? You'd have the same base, 7, and then you'd have x minus x, same base, you add the exponents, so 7 to the 0. And then plus the last one squared, so 7 to the negative 2x. So to me, that looks like 49 to the x, then plus a 2, because 7 to the 0 is 1. And then this would be what? 1 over 49 to the x? That's a crazy answer, but that's what I'm seeing. And I'm feeling pretty good. How about you? All right. Why don't you try one? And we'll be right back. Nice work on those. Now, as I was looking back, I'm about to do the factoring ones down below, and I noticed up here, as I was waiting for you, we have a 2 to the x here and a 2 to the x here. So I just thought it would be interesting, and I hadn't tried it yet, is what if I have the 4 to the x plus, and then if I factor out the 2 to the x, I would have 1 plus 3 plus 3, or 4 to the x plus 2 to the x times 4 plus 3. I don't know, does that look any better? I don't know. Not 100% sure that I like that any better than what I had, but it is only 3 terms, so that's kind of nice, better than 4 terms. But realize, and that's the joy of math, that you have 2 answers that are the same, just one might look a little prettier. So again, I like to call that good manners. All right, what about this one? Next, let's try some factoring. So how about factoring? Can you work this backwards, right? So factoring, maybe in this first problem, I see reverse distribution. So what do they have in common? Like, it looks like they both have a 2 to the n, but oh, that first one has a 2 to the n plus 3. What a bummer. Well, how could you actually write that? 2 to the n times 2 to the third, right? That would be 2 to the n plus 3 plus 2 to the n. So I just rewrote the n plus 3 as this. Now, the cool part is they both have a 2 to the n in them, so I could pull that out, and I would be left with 2 cubed plus 1, right? And wait, 2 cubed is just 8 plus 1, and I am seeing 2 to the n times 9, or even 9 times 2 to the n. Looks maybe even prettier, because I like my variable last. Is that okay? So that's one way to do it, and it's just something you got to get comfortable with and hopefully see, and we don't always see it. Like in this next one, I see a base 2 and a base 8. Now the first one was nice, it had base 2 and base 2. This doesn't, but wait, isn't 8 just, if I write this as 2 to the n plus 3, isn't 8 just 2 to the n? I'm sorry, 2 to the third, right? Because 2 times 2 times 2 is 8. Oh, nice. And if you know that trick that we just did, 2 to the n plus 3 is really just 2 to the n 2 times 2 to the third plus 2 to the third. Now they both have a 2 to the third in them, and that would leave me with a 2 to the n plus 1. And there's my answer. Or if you want, somebody might write it as 8 times 2 to the n plus 1. That would be acceptable too. So I think either of these would be nice. And you never know which one they're going to give you, right? So there you go. There is factoring out a common factor. Same thing's going to happen here. Ooh, what do I have here? I see a 2 to the 3n. So let me see. That could be 2 to the n times 2 to the 2n. You might know why I would have picked that. Is because, again, same base, add the exponents, you'd get 3n. So I'm legit. Plus, and then I'm going to leave 2 to the 2n here. Now you probably realize why I picked to break it up that way, because they both have a 2 to the 2n. So I have 2 to the 2n, and then I have a 2n plus 1 left over. Hope you see where I'm getting at, right? I pulled this out, and so what's left? A 2n plus, you better have that placeholder, so 1. Anything else I can do here? Probably this good answer. The 2 squared is kind of bothering me, so I might make that as 4 to the n times 2 to the n plus 1, just because I like it. I think it looks a little prettier. Again, what do you think better manners are? Which one do you think is prettier? I got to just be prepared to write both, because if this were multiple choice, and I know IB doesn't do any multiple choice, if they did, then it could be either one. What about the next one? Ooh, look at that. That's like almost difference of squares if that 4 to the x could have been written as a square. Wait, it can, right? 2 to the 2x. We're just doing it backwards now. So now it's like, if you want, you can think of that as 2 to the x squared like that, right? Because if they have 2 exponents, you just multiply them together. Unless the x was getting the exponent, then that'd be a little different. But this is the 2 to the x is getting the exponent. So it looked like that. That is definitely difference of squares. So one factor would be 2 to the x plus 3, and the other factor 2 to the x minus 3. And I was just helping my daughter do this in algebra, but she was of course not doing it with something that ugly. She was doing it with, x squared minus 9. There it is, difference of squares. Oh, and what about this last one? That one looks interesting. I see a 3 to the x, and I know I could write this as 3 to the x, so that might help. So let's go 3. What is going on? Hey, don't you touch over there. 3 squared to the x, right? Plus 4 times 3 to the x plus 4. That is 3 to the x squared plus, oh my gosh, this is just a quadratic, right? Now, IB loves to do these nasty quadratics to you. This is not uncommon, where you can see that this looks a whole lot just like x squared plus 4x plus 4. Do you see it? It looks really like that. Just let, how can I write that? So a crazy way to think of this is, if you look, this is a hidden quadratic, right? It looks like this. So let me do it kind of a neat way. I'll say, let 3 to the x equal m for Meyer. Oh, then m, this would just become m squared minus 4m plus 4. Now, why did that pause up? Nobody wants to see you. Go away. Then that's easy to factor, right? That's just m minus 2, m minus 2. Therefore, if I take the m out and put 3 to the x back in, I get 3 to the x minus 2 and 3 to the x minus 2, or 3 to the x minus 2 squared. What? That was crazy, right? So that was IB doing their little trick where they love to do a quadratic that's kind of hidden with something else. And in this case, they put an exponential that was hidden in a quadratic just to blow your mind. So that's how much fun you can get. All right, let me ask you another question, and we will be right back. All right, great job on that one. And now let's get into things called simplifying. We all like to have things a little simpler, don't we? It just makes our life a little easier. So let's go ahead and do that. Look at this first example. Why is it pulling up my calculator? It is very touchy, this screen. And I do not want my calculator right now. Let's see. How could I write this? This is 6 to the n, and that is 3 to the n. So is there anything fancy I can do there? Well, I could say that this is 6 over 3 to the n power, which would just be 2 to the n, right? And there you go. That looks a whole lot prettier, or a whole lot more simple than it would have before. I'm trying to think if there was anything else I could have done there. I could have written 6 to the n as 2 to the n times 3 to the n, right? Because they're different bases, so this isn't a case where you add them. So that would just be 2 times 3 to the n, or you even could have thought of it as, maybe you would have thought of 6 to the n as 2 times 3 to the n, like that, and then that's when it would come into this form. And these would both be over 3 to the n. And then the cool part there is you'd be like, those cancel, and you get 2 to the n. So either way, I could see that as 2 to the n. All right, what about this one? Same kind of thing. I could just go 4 over 6 to the n, which then would be, what, 2/3 to the n. I don't know if that looks very pretty. That'd be 2 to the n over 3 to the n. I don't see anything fancy pants there. That's kind of a bummer. I could do that as 2. That's one way. The other way I'm thinking of is I could have done this as 2 to the n times 2 to the n. This would be 2 to the n over times 3 to the n. Oh yeah, and that would just cancel these. That leaves us with the exact same thing. So that's about as fancy as I can get there. All right, what about example A down here? I see, this is 3 to the n plus, now this could be 3 to the n, 2 to the n. Right, so that's kind of nice. So I could, I could have 3 to the n factored out and have 1 plus 2 to the n for the top, and the bottom I would just leave as 3 to the n. Then a little, and we got 1 plus 2 to the n as our answer. Here I got, what is this? This is 2 to the m times 2 to the 2 minus 2 to the m all over 2 to the m. I could pull out a 2 to the m, and I would be left with 2 to the 2 minus 1 all over 2 to the m. And then I go, and I'm left with, oh, that's kind of neat. I'm left with 4 minus 1, which is 3. That answer is just 3. And here in the last 30 seconds, we got one more. Let's see. This would be 2 to the m times 2 to the 3 plus 2 to the m all over 9. And I pull out a 2 to the m, and I'm left with 2 to the 3 plus 1 all over 9. That really didn't, oh wait, yes it did. That is 2 to the m. I have 8 plus 1 is 9 over 9. And I get 2 to the m. It's going to cut me off, so have a great day. Stay happy.